All right, so in this video, we are going to wrap up section 1.6 in our section talking about other types of equations. And so, as I mentioned in the last video, where we did kind of some weird factoring techniques that we don't see very often, the second thing we want to make sure we cover in this section is the idea of radical equations or square root equations. Once again, I apologize for a little bit of typo I had in the notes that I put on Canvas, but as you can see, I adjusted those here for the video as you are watching and filling in your blank notes. So, not really a new technique we have to cover. We're going to kind of talk about some old things we've covered already. But one thing I do want to make sure I mention before we start this last technique for 1.6 is that whenever you are solving a radical equation, which means the original problem has a square root in it, you have to, as you can see, I have highlighted in blue already, you must check all of your solutions before you type them into your homework, quiz, or test assignment. That's because what you have to make sure you notice is that in a square root problem, your final answer cannot be negative. Now, I know we would add negatives in whenever we took a square root in previous sections, but since the square root is already built into the original problem, you cannot have a negative answer on the opposite side of a square root. So keep that in mind as we work these problems. So on number 5, you've got the square root of 2x plus 1 is equal to positive 7. Now, as we know, if you have a square root and you're trying to get rid of it, you want to do its opposite. Well, the opposite of taking a square root is squaring something. So once you get a square root by itself, all you are going to do in order to get rid of it is you're going to square it. But in any equation in mathematics, whatever you do to one side, you need to also do to the other. So you notice that I'm going to end up squaring both sides of this equation. So when I do that, so I square the square root, and those end up canceling. So that just gives me a 2x plus 1. And on the right, you can use your calculator if you need to, but 7 times 7 gives me 49. Automatically, you will see this problem becomes a lot easier to solve. So let's go through our basic solving techniques. I will subtract the 1 to the other side, which gives me 2x equal, oops, sorry, my pen jumped. 2x equals 48. And then if I divide both sides by 2, 48 divided by 2 gives me an answer of 24. Now, like I mentioned earlier, you want to make sure before you type in your answers to any of your assignments that you check that this answer makes sense. So what I typically will tell you in the next 2 or 3 problems is you want to make sure that if you plug your answer in, it does not give you a negative number on the right-hand side. The good news with this problem is that since the 7 is the only thing on the right-hand side of your equation, there's no way 7 can be negative because there's nothing there that would change it by plugging x in. So we kind of get lucky here on the first one in that our only answer, which is 24, is the solution to this problem. But you're going to see on the next couple, you will have to actually check the answers that you get, and you'll see how those are a little bit different in just a second. So speaking of that, let's move to number 6. You have the square root of 16 minus 6x, and then minus x needs to equal 0. Now, I know in previous sections or in previous videos, when we were trying to factor stuff or solve equations, we would want to have it equal to 0. The problem with this one is that in order to get rid of a square root, you're going to have to square it. But you don't want to square a square root when it has something else with it. So I don't really like the fact that this negative x is here, because that's going to throw off my squaring technique. So what I'm going to do here is I'm actually going to move that negative x to the other side by adding x to both sides of this equation, which will give me the square root of 16 minus 6x is now equal to positive x. And what's really nice here is we now have the square root on one side and we have everything else on the other. And so just like the previous example, to get rid of this square root, I am not only going to square it, I'm going to also square the other side of the equation to keep everything equivalent. Well, when you square a square root, it cancels, which gives you 16 minus 6x. And if you square x, you get x squared. Now that the square root is gone, this is where you're going to have to go back to your old techniques. Now that it's just an x squared term, we learned in section 1.4 that you can only solve an x squared problem if it is equal to 0. So in order to make this equal to 0, I'm going to move the 16 and I'm going to move the negative 6x to the other side by doing their opposites. This will cancel, and you will get a 0 on the left, and on the right, you will get an x squared plus 6x minus 16. So typically from this point, I'm going to try to factor this as one of our traditional trinomials. And so we want to think of two numbers that will multiply to get negative 16, but they will add to get positive 6. So once again, if you need to pause the video to think about them on your own, you can do that. The two numbers you should be getting here to meet this criteria are positive 8 and negative 2. So if we set both of these equal to 0, so x plus 8 equals 0 and x minus 2 equals 0, and solve them individually, on the first one, you would subtract 8 from both sides to get an answer of x equals negative 8. And on the second one, if you were to add 2 to both sides, you would get a second solution of x equals positive 2. Now remember, we have to make sure that these answers make sense. So what you will notice is that if we go back up here to the top, and if we were to look at the problem before we squared it, where you had the square root of 16 minus 6x equals x. This was the original square root problem that we hadn't done anything to yet. What you have to notice here is that if you were to take both of your answers and you were to check, remember I told you at the top, a square root cannot equal a negative number on its own. So if you notice, if you take both of these answers and try to put them on the right-hand side, if you plug negative 8 in, that's going to give you a negative number on the right-hand side. That means you can't use negative 8 as an answer. That's why we check our solutions. If you plug positive 2 in, there's nothing wrong with having a positive number on the right-hand side. So even though the mathematics had us find two answers, which is correct, you have to check your solutions whenever you're solving radical equations. That's why I'm going to stress it a lot, because I know that if anybody makes a mistake on the test, it'll usually be because they forget to factor or to check, their solutions at the end. All right, I want to do one more like that because I hate to just do one like that and leave it alone. So on the next slide, let's do the exact same idea. I would like you to solve this radical equation with me, and when we're done, we will check our solution to make sure it's valid. So on number 7, you have x minus 7 equals the square root of x minus 1. Now, nicely on this one, the square root is already by itself on one side of the equation, so I can go ahead and go straight into my squaring technique. So I'm going to square both sides of the equation. Now, on the left, when you square x minus 7, that's going to be the same thing as multiplying x minus 7 times itself, which I'll do in just a second. On the right, if you square a square root, that's a little bit nicer. That's just going to cancel and give you x minus 1. If I do my FOIL technique on the left-hand side, so FOIL, first would give me x squared, outer would give me negative 7x, inner would give me negative 7x, and last would give me 49 equals x minus 1. If I put my two x terms together on the left, you will get x squared minus 14x plus 49 equals x minus 1. And now that your square root is gone and you have an x squared, which is a quadratic equation, remember you need to make this equal 0 before you start to factor. So to make this equal to 0, I'm going to move the x and the -1 to the left-hand side by doing their opposites. That way everything cancels on the right to give me the 0 that I desire. And on the left, you should have an x squared. -14 minus 1 more would be -15x, and 49 plus 1 gives me 50. At this point, you can now use your factoring techniques to factor trinomials. So to factor this trinomial, we are trying to think of two numbers that multiply to get 50, but they will add to get -15. Once again, like I always do, if you'd like to pause the video to think about these two numbers, go ahead and do that now. And so if you factor, or if you find these two numbers that meet these designations, you should get -10 and -5. All right, coming up here to the next line, we need to set both of those equal to 0. So over here on the right, I'm going to take x minus 10 equal to 0 and x minus 5 equal to 0 and solve them both individually. On the first one, I'm going to add 10 to both sides to give me a possible answer of x equals 10. And on the second one, I'm going to add 5 to both sides, which will give me a possible solution of +5. But remember, there was an original square root in this problem, so we must now check our answer. So if you were to go back to before you square, that's what we always do. You always go back before you square. You had an x minus 7 equaled a square root term. Remember, what's on the opposite side of the square root cannot be a negative answer. So if you were to take both of your solutions and check them, you might notice that one of them is going to cause a problem. Beginning with the first one, if you plug 10 in, 10 minus 7 is +3. That's okay. We can have a positive number there. So x equals 10 is a good solution. But if you try to plug the 5 into the left-hand side, 5 minus 7 would give you -2, which is not allowed when you're solving a square root equation. So therefore, x equals 5, we have to throw out that answer and only use the answer +10. And so that will be the only solution of this radical or square root equation. And so in this video, we talked about how to do radical equations or square root equations, which was the second technique of section 1.6. All right, so that wraps up section 1.6. In the next video, we'll move into the next section and talk about another technique that might be beneficial as we go forward.